we're now ready to solve this problem, right? Where we are given two balls colliding, their masses and starting velocity, and we have to find their velocity after they collide, right? Given that no kinetic energy is lost, right? Given that this is perfectly elastic. So the equations that we need, first one, let me write that down, is the momentum conservation equation. M1 U1, the momentum of ball 1, plus M2 U2, momentum of ball 2. This is equal to, after colliding, momentum of ball 1, M1 V1, momentum of ball 2, M2 V2. So this is one equation. Now for the case where no kinetic energy is lost, the next equation is that this relative speed of approach before they collide, which is just the difference between the two velocities. And the relative speed of separation is after they've collided, so v2 minus v1. You just take the velocity of one ball minus the other one. They are equal. Okay, except that I must add a minus sign to one side because one is approach, one is separation, so the motions are opposites. So we have these two equations. We know all the numbers except for v1 and v2, which we have to find. Okay, right. So let's try and do it then. Let's now I would normally want to rearrange the equation to solve for v1 and v2 before putting in the numbers. But let's try putting the numbers this time because there are quite a lot of symbols and the numbers don't look too complicated. So let me call this equation 1. It's always useful when we have more than one equations to label the equation that we are going to use later. Okay, so equation 1. See what we can do with it. This is M1 U1. Okay, so 0.5 times 2. I'm just going to be quick and write down the answer directly. So 0.5 times 2 is, I'll write it down anyway. So 0.5 times 2, I just write it down, plus M2U2, M2U2, so 0.3 times minus 1, 0.3 times minus 1. And then M1 V1, okay, V1 we don't know, but we know M1, so let's see how we write it. So this M1 is 0.5, you know from there. V1 is unknown, so 0.5 times V1 plus M2 is 0.3, so 0.3 times V2. 3 times V2, so I have one equation there. And for equation 2, I have minus of U2 minus U1. U2 minus U1, so that's minus 1 minus plus 2. So minus 1 minus plus 2 is the same as just 2. And V2 minus V1, on the right side, V2 minus V1. So we have these equations, okay, 2 equations and 2 unknowns and some numbers. So in principle, we should be able to find the answer. Right. So let me running out of space, so let me move these equations, or let me just clear up the top. Let me just clear up the top figure and continue from the top. So let me continue working from the top, and again, I'll label these new equations. I'll call this equation number 3, and I'll call this equation number 4. Okay, and I'll start simplifying this. Equation number 3. Okay, so this is 0.5 times 2, which is 1. That is minus 0.3. Okay, and on the right side is the same. We don't know V1 and V2 yet, plus 0.3 V2. Okay, and from equation 4, so we want to simplify that. So minus 1 minus 2 is minus 3, negative minus 3 is 3. So minus V1. Okay. So how shall we do this? That's a V1, isn't it? Okay. Let me call this equation 5. I'll call this equation 6. Alright, I can do it by elimination. Yeah, okay, I'm going to okay, I noticed that I have 0.5 times V1 here, and I have a minus V1 here. So okay, well, I'll do it by substitution. So let me make V1 the subject. I'll bring V1 over to the left and bring 3 over to the other side. So V1 is V2 minus 3. Okay, so now that I know V1, I can substitute into the V1 in equation 5. So what I'm going to do is I'm going to say that I will substitute this into equation 5. Okay, and if I do that, let's see what I get. In equation 5, the left side is 1 minus 0.3, which is 0.7, and so V1 goes into here. So this means 0.5. So V1 is actually V2 minus 3, right? V2 minus 3 plus 0.3 V2, 0.3 V2. Okay. So let's simplify this. So this is 0.7 equals to 0.5 V2 minus 0.5 times 3 is 1.3, 1.5 actually, plus 0.3 V2, 0.3 V2. Okay, so move the minus 1.5 over to the other side. So that will be added to 0.7, and this gives, what does this give? 2.2. 2.2 equals, and 0.5 V2 plus 0.3 V2 gives 0.8 V2. So therefore, need some more space. Clear this part up. So therefore V2 is equal to 2.2 divided by 0.8. Okay, that's it. 2.2 over 0.8. So that would be 11 over 4. 11 over 4, or if you want decimal, so 2.75 meters per second. Yeah, so that's V2. Okay, and now let's find V1. V1 we can find from here. Okay, let me call this equation 7. So from equation 7, we have V1 is V2 minus 3, V1 is V2 minus 3, but we already know that V2 is 2.75, so 2.75 minus 3, so that's 0.25 with a minus sign, meters per second. So there we are, we have the two answers. V1 is minus 0.25, so minus means that it's going to the left with a speed of 0.25 meters per second, and V2 is positive, no sign means positive, so it's V2, that means ball number 2 is moving to the right, would move to the right with 2.75 meters per second.